Hello everyone. This is Vyom Kumar Gupta, currently pursuing PhD in Triple ITA under the mentorship of Dr. Sunny sir. In this tutorial, we are going to discuss how we can simulate in hardware using EDA tools, whereas EDA stands for Electronic Design Automation. So now, first we will understand the file system. So this is a Linux operating system, and you can also do this simulation in Windows and Mac, but the Linux supports exclusive file systems and other too many parameters, so it is easier to done simulation on Linux. So the place where my cursor is moving is known as working directory in the terminology of Linux. So if we are going to use any similar EDA tools, we have to be conscious regarding the directories. So you are going to simulate your files in this directory. So you have to open your terminal, or you have to open your tools in the same directory. Okay. So if you want to know about the working directory you are presently existing when you are using terminal, you can simply type pwd and it will show you the present working directory here. Now we will discuss the file system. Here we will discuss two files. One is named hardware description of AND gate.v. Another one is named as AND gate test. So hardware description is just simply a hardware description of your hardware you are going to simulate or with an EDA tool. So this is the module of AND gate, and the one thing is important here. We have used assign statement to perform a AND function, logical AND function. It represents that we are using behavioral level of abstraction to design this hardware. So here is the test bench of this hardware. Test bench stimulates the hardware. This command is instantiating the hardware with the same name as you mentioned in your hardware description file. In this first initial begin block, we are putting the values of input just like we are making a truth table for AND gate. There are two additional commands which is used to generate a VCD file. A VCD file consists the information of simulation results, waveform, and the values of input and the recorded response of the outputs with respect to the inputs you given in test band. Now we are going to do the simulation and deleting the previous files. First of all, we are going to open the terminal. Open in terminal in the same working directory. Now, first we will invoke iverilog. Log tool is already installed in the system. We are just invoking. To invoke that iverilog tool, we have to choose a command. So there is a command iverilog which simultaneously simulate the test bench and the hardware. So I am going to write that command. And then I'm going to write the file names. to hit enter. Now this command generate this a.out file. This a.out file is the simulated file which has been simulated on iverilog tool, and this will have the information, but we cannot directly retrieve the information from this. If you will open that file, you will have nothing specific information about the design and what's going in the design. And basically we are going to do formal functional verification here. Functional verification means the functionality test of hardware. We have given a set of input in the test bench and we have given a hardware description. Now we are telling a tool, electronic design automation tool, to simulate that hardware with these input values and verify that the design is working correct or not. And same you do when you design a digital circuit, either combinational or sequential, when you just draw the truth tables after designing, after structuring your block diagram, get level block diagram, and same things EDA tools does. Now we will convert this a.out file into the VCD file, and the command we will use vvp a.out. Then I will hit enter. So dump file n.vcd operand for output is written here and the file is here. If you will open this file, this file supports GTK tool, GTK wave tool. A GTK wave tool is a visualizer that visualizes the .vcd file, and you can visualize the signals used in your hardware. Here the A and B are the input signals and Y is the output signal, and this will show you the waveform of the design. Now you can do further analysis if you want, like timing analysis, power analysis, anything you want to check in your design, you may verify with these waveforms. Thank you.